Probably the most common scenario for using a git rebase is this one. Let's say you're working on your own feature branch, which has not been pushed or shared with anyone yet. As you're working on the feature branch, making your commits to it, your teammates are also making commits and merging them into the main branch. Sometimes you need those changes to continue working on your feature. For example, if those changes are some important bug fixes or other changes that your feature depends on. To get those changes, what you could do is just merge the main branch into your feature branch occasionally. When you do this, Git will automatically create a merge commit. As you keep working on your branch, you might have to do this multiple times, each time creating a new merge commit. Doing this more often is also generally a good idea, because if there are merge conflicts, the longer you wait with the merge, the bigger they become and the more difficult they are to fix. Once your feature is done, you'll want to merge your feature branch back into the main branch. This is most often done with a pull request on GitHub. Once you're ready to merge the pull request, you can hit this button. It will merge your feature branch into the main branch. The same thing can also be done via command line with these commands, but in many teams you don't have the permissions to do this, because the main branch is protected. In any case, once you do the merge, a final merge commit will be created, this time on the main branch. All the other commits will be left in history, even after the feature branch has been deleted. If everyone on the team does this, after time, the commit history will be quite full with these extra merge commits that don't really add any meaningful information. This makes it quite difficult to navigate the history, for example when you're looking for a specific commit where a feature was worked on or a bug was introduced. Here's an example that shows a typical history with lots of merge commits, and you can also see that the branching history is getting quite confusing to decipher. For some people this isn't really a problem, and for smaller teams and projects you might not even care. In that case, you don't ever need to rebase at all, and you can just keep using git merge. But if you do care and want a more linear commit history, here are two ways to fix this. You can either squash upon merge, or do a git rebase. Or you can do both. I'll focus on rebasing for this video, but let me know in the comments if you'd like to see another video that explains what squashing on GitHub does. Okay, to see what rebasing does, let's go back to the beginning, when we initially created our feature branch. Remember, our goal was to get these commits from the main branch into our feature branch, but without creating an extra merge commit. This is exactly what rebasing does. If we switch to our feature branch and run git rebase main, Git will modify the commit history. It'll temporarily put these commits to the side and then reapply them one by one, but this time with the latest commit on the main branch as the ancestor. It's called rebasing because before, this commit was the old base commit that our feature branch was originating from. But now this commit is the new base commit. So we've rebased our branch. The branches are still separate, it's just that our feature branch now contains all the latest changes from main, and all the other commits are applied on top of that. You can rebase your branch multiple times as needed. The big advantage of doing this is that no merge commits were created, even once we finally merge our feature branch back into main. This kind of merge that leaves the commit history in a linear state is called fast forwarding. This linear history is the main advantage of rebasing, since it makes it much easier for you and your teammates to navigate. It's not all sunshine and rainbows though in rebase land. There are also some major downsides to rebasing. First of all, the one golden rule of rebasing you should always follow is, unless you really know what you're doing, never rebase any commits you've already pushed. Why is it so bad to rebase pushed commits? Let's take a look. As you probably know, every git commit is identified by a unique hash. When you push to a remote, for example to GitHub, those commit hashes remain the same. However, when you rebase a branch, the commit hashes for it will change. Since you've already pushed that branch, the hashes on your machine and the remote no longer match up. Git will get confused and won't be able to identify that those commits are actually the same. This is particularly bad when other people have already pulled from the remote. In the worst case, this could lose your team some work because some commits get overwritten. This can't ever happen if you only use git merge, since git merge doesn't rewrite the history and keeps all commit hashes the same. If you're not quite sure if you've already pushed your feature branch, just run git branch-a to see all your remote branches, and if the feature branch is listed there, you really shouldn't be rebasing it. If it's not listed there, you can safely rebase. Another thing we unfortunately have to worry about are conflicts. When you rebase, of course it could still happen that the latest changes from the main branch and your changes are in conflict. In that case, you have two options. Either you abort the rebase entirely, or what I would recommend instead, you fix the conflict while you're rebasing. If you've never fixed a merge conflict before, not even when using git merge, you should probably learn about that first. I already have a full video on that on my channel, link in the description. With rebasing, fixing conflicts is unfortunately a bit more complicated still, but I guess that's a common theme around Git. You see, Git rebase will take the commits on your feature branch, temporarily put them to the side, and then reapply them one by one. This means that each commit could potentially cause new conflicts, and you might have to go through multiple stages of conflict resolution. Let's go through a quick real-life example here. I'm on the feature/login branch, which contains 3 fresh commits. They all originate from this commit on the main branch here. There are 2 additional commits on the main branch that I'd like to rebase on top of. So basically making this commit the new base commit of my feature branch. I've deliberately set up the repo in this example in such a way that these 2 commits will cause merge conflicts when reapplied during rebase, while this commit will not cause any conflicts. Okay, now let's actually do the rebase, and as you can see, I'm running into the first conflict. If we run git status here, we can see that the rebase is still in progress. When running into a conflict, Git will pause the rebase. We can see here that the conflict occurred when trying to apply our first commit, and there are still 2 more commits to go after that. Fixing a conflict during rebase works almost the same as during a merge. Git will place conflict markers in all conflicted files. You then have to open them in your favorite text editor and manually fix any conflicts. You can do this by removing the conflict markers and picking the code that should actually stay in the file after the rebase. Once you've fixed all the conflicts, you need to run git add for all conflicted files. If this was all a bit too fast, please do check out that other video in the description. I explain it in much more detail there. Now, compared to a merge, the main difference during a rebase is that instead of committing your changes, you need to run git rebase continue. When you run that command, Git will open a text editor to let you change the commit message. By default, this will open Vim, which is a terminal-based text editor, and it's notorious for being confusing to newcomers. If you've never used it before, just hit the escape key, then type :WQ, which stands for write quit, and will just save and close the file. By doing this, you're basically telling Git that you're fine with leaving the commit message as it is, and you don't want to change it. By the way, if you want to change the text editor that Git uses for commit messages and other actions, I have a video on my channel showing you how to do that. Link in the description. After you close the file in Vim, Git will automatically continue with the rebase. Git will apply the next commit of the feature branch. The way I've set up this example repo, this commit won't cause any new conflicts, so Git can just apply it automatically and move on to the next commit. The third and last commit is conflicting again, so Git paused once more to let us fix the conflict. Let's do that just like we did before and run git rebase continue again. Since there are no more commits left, this concludes the rebase and we're done. If you want to be sure that you're finished with the rebase, run git status to check that you're no longer in a rebasing state. That's it. Now you've successfully rebased your branch. There's also another way to do rebasing, the interactive rebase, which allows you to undo, squash, or even reorder commits. Let me know in the comments if you'd like to see a full video on that. By the way, I've been teaching in-person courses for Git and other programming topics for a few years now. And I noticed that while a lot of people gain some insight from videos like this, actually implementing the advice and changing your workflows can be a different beast entirely. Sometimes it really helps if you have someone guiding you personally along the way, and that's why I'm going to offer some live online workshops later this year. The workshops will have explanations, like in this video, but they'll also have some bite-sized exercises for you to try on your own and get immediate feedback from me personally. So if you like my style of teaching and you are ready to actually get good, just go to philomatics.com/gitworkshop to learn more. I really enjoy working with people on a personal level, so I'd love to see you there. I'm still really new to YouTube, so I'd love to hear your feedback. This video alone took more than 30 hours to create, so if you enjoyed it, it'd be really great if you subscribe to the channel. I have more videos on Git in the works, and I might also try out other programming related topics. If you have any ideas or wishes, please let me know down below. I'll also post exclusive non-YouTube content on my website, philomatics.com, in the future. So if you'd like to get notified when that's released, please leave your email address there. Have a great day, and thanks for watching.